Hello and welcome. This is a lesson on water. Get ready to learn. We have water here in solid, liquid, and gaseous form. Liquid water takes the shape of its container. Think about a glass of water. Doesn't need a top. Well, at least not on Earth, where they've got gravity keeping it in. The molecules can move around in a liquid, and because there's a slight charge, water is a polar molecule, and we'll get to that in a little while. But it just means like the pole of a magnet, the north and the south. Water has a slight charge on one side and a slight other charge on another side, positive and negative. Makes it very special. Water changes state when heat is added or removed. Remember, there's no cold. It's the absence of heat. So we talk about adding or subtracting heat. Freezing, melting, and evaporation are physical properties of water. And because of this polar molecule, it combines with many, many things. And that's why it's known as the universal solvent. It can dissolve things in water. So, why is this important? Because of a slight charge, water molecule is very special. It's that polar charge. Unlike other things, water expands when it freezes. It gets smaller and smaller and smaller and more dense and more dense and more dense. But then, somewhere around 4 degrees centigrade, it starts expanding again. That's why ice floats. Otherwise, it would be bouncing around in the liquid. But if it's less dense, it's going to float, and some of it is going to stick out of the water. Okay, here we go. Did you know liquids take the shape of their containers? The molecules can move around. They maintain their own volume. You can't compress them, or at least it's very difficult to, if at all. Unlike air. The attractive forces of molecules is a major factor in their behavior. Remember that polar, positive, negative sides. And because so many things are dissolved in water, it's known as the universal solvent. There's our old friend H2O. There's the water molecule. Notice you don't know if this is solid, liquid, or gas. We don't know what temperature it is. But it's always 2 hydrogen atoms and 1 oxygen. Okay, here we go. Water is a polar molecule. Here's the hydrogen, here's the oxygen. But because of the way that the atoms share electrons, the way oxygen and hydrogen atoms arrange themselves, giving a slight charge, makes water a very special molecule. This part is weakly negative. It's not a lot. But this part is negative and this is positive. That comes into play a little later on. when they come close together, just like taking two magnets in the north and the south, well, the positive ends with the negative ends, they provide attraction. Like the poles of a magnet, water molecules are attracted to each other. Now, when you have a glass of water, inside the water, you got water above, water molecules above, water molecules below, water molecules to the left, water molecules to the right, water molecules in front, and water molecules in back. So you're surrounded by water molecules. But at the surface, you got water molecules below, water molecules in front, water molecules in back, water molecules to the left, water molecules to the right. Oh, you don't have water molecules above. But it kind of fall over and form more bonds. This forms a skin on the water surface. It's called surface tension. And that can make steel float. Let me show you a picture of that. That's a paper clip floating on top of water because of the top layer of atoms not having atoms above hold on to. Surface tension. Solid water, ice, floats. We all know about icebergs and Titanic. Water molecules, they spread out due to their charges. Their volume decreases as the temperature decreases, just like other things. But their minimum volume is at 4 degrees centigrade. Then it starts increasing. When frozen, 0 degrees, it actually takes up 9% more volume than when it was at 4 degrees. It's because of these charges and the way the atoms arrange themselves. That's why if you ever look at a can, the bottom of it has this dimple in here. It's pushed in. That's so that when it freezes, like you leave it in your car or you leave it outside, or you put it in the freezer instead of the refrigerator, that will pop out. And this is designed so that it will account for 9% increase in volume in a frozen liquid, or a liquid when it freezes. That's why that bottom looks the way it does. Ice, water, and vapor. You can identify what state it is by what container it's in. It exists on Earth in all 3 states: solid, needs no container; liquid, no top needed, fill the glass, and as long as there's gravity, it's going to stay in there; but a gas must be contained. Here's our old friend, water molecule. Water, these molecules are all the same. It's because of the protons, neutrons, and electrons and the configuration of the atoms themselves. So the hydrogen atoms are always at a 104.45 degree angle. That's this angle here. 104.45. And the distance is always the same. Now, when we change state, we go from a liquid to a gas. Water boils at 100 degrees centigrade or 212 Fahrenheit. But it also goes the other way, liquid to a gas, or gas to a liquid. Condensation at 100 degrees centigrade or 212 comes out of the air and condenses onto a cooler surface. Change of state again from a solid, ice, to a liquid. Ice melts at 0 degrees or 32 Fahrenheit, goes from a liquid to a solid by freezing at the same temperature. So it depends on which way you're going. If the temperature is going down, you're going to be freezing. If it's going up, you're going to be melting. Now here's the interesting thing. Changes state from a solid right to a gas without going through that liquid state. It's called sublimation. That's why, if you've ever had ice cubes in the freezer and they get smaller over time, it's because of sublimation. It's going right from a solid right into a gas. And from a gas right to a solid, called deposition. In the center of every snowflake is a little piece of dust. And that allows the vapor, the water vapor in the air, to give up its heat to that little piece of dust right in the center and go right from a gas to a solid. Because, remember those angles? Because of those angles, we always have 6 sides. So, why is this important? Because of the slight charge, a water molecule is very special. Water expands when it freezes. You don't want to leave closed cans of water or they're going to freeze. And ice, made out of water, floats because of that angle that the molecule makes. There's your lesson on water.